Hi class. So now we're starting a new unit and I wanted to just give a brief overview of what we're going to be doing in our next unit. To help you along, I wanted to also just show you where to get the information that you needed to be successful in this course. So I wanted to just take a minute to get us all back on the same page, so to speak. So on Sunday nights, I will be having your announcements posted and ready to go for the following week so that you can somehow figure out a way to get everything that you need in place. So what it'll do is just highlight what we're going to need as far as our file types and any type of readings that you're going to need. Now, along the way throughout the week, I will be recording videos such as these just to help to get us started so that we can go into the classroom the next day and just simply apply what we're doing. So just to briefly give you an overview once again of our Canvas page, you'll locate everything here on the announcements section. Once you go into the announcements section, you're going to locate, for this past week, I had it done for September 9th. It'll very clearly just let you know when your calculations test was. And then notice here how it will explain that I wanted you to read over the 3 documents that are placed into your Chapter 1 folder. And if you're wondering where those are, you would come down here to your files. And you would go here to your Chapter 1, Science of Matter, and these are the 3 things that you should start perusing to get yourselves ready and used to the material coming up. It won't take you too long to read through this chapter, just to give you an overview of what we're doing so that when you come into the classroom we can solidify your understanding. So today what I'm going to do is go over a couple ideas here in this Unit 1 PowerPoint because we're going to be directly applying these in both an activity this week and into a laboratory investigation. As a reminder, you do have your density lab from last week that is going to be due this week depending on which day you have me. For my L days, it's going to be on Fridays, and for my L days, it's going to be on Thursday, and for my N day, it'll be on Friday. Unless, of course, you're L3, then that's next Monday. Okay, so now that you have a little bit of an overview here of where to find these documents, if I say under the announcements, any type of assignment that you have, again, you will also find these here under the files. I have not put any assignments in yet for Chapter 1 since we're just starting. So what we're going to do in class is an activity that has to do with the separation of matter. Okay, so just to go over this briefly, everything on the earth is matter. Antimatter exists out in outer space, and as it's touching matter, it's extending our universe into regions of unknown areas. So what's here on earth is matter. So you can put everything right here under this area. So now you can start to think to yourself, can it be physically separated? If it can be physically separated, then you would jump down here to the mixture. And we're going to further define that in a couple minutes. If it cannot be separated physically, that means either by boiling it or evaporating it, or freezing it or something of that nature, if we can't filter it, then it's going to be coming down this area. That means that we're going to have to apply, well, that's going to be more along the lines of chemical. But if you can't separate it physically, then you're down here in this area of a pure substance, okay? If you have a pure substance and it can be separated chemically, meaning yes, then you have a compound like salt, NaCl. That's 2 or more elements mixed together to make a compound. If it cannot be separated chemically, then that means it is as simple as it's going to get. That means you have an element, and anything on the periodic table is considered an element. You cannot further chemically separate that. So that's just an overview. Now, getting back to our mixture over here, this mixture can be further divided. So looking at this concept map right here, I have our mixtures. And if it has an even distribution, that means that it's uniform throughout. We call that a homogeneous mixture. If it's unevenly distributed, then we call it a heterogeneous mixture. Now we can take mixtures and separate them by different physical means. One of them is filtration, another is distillation, chromatography, and we're going to be working with these ideas in the lab. So, as I mentioned earlier, we can further separate these mixtures down into two different types here: heterogeneous matter and homogeneous matter. An example would be this nice yummy chocolate chip ice cream. Notice it's not uniform throughout. We actually visibly can see little chunks of chocolate chips. We can see ice cream. So it's not considered uniform throughout. That's considered heterogeneous. If you look over here to the right, we see something called homogeneous matter. That means it's uniform throughout and you cannot see individual components. An example would be salt water. Okay, you have the salt, it's mixed in here and it's uniform throughout. So this is just a little bit of a wrap up. If you were to actually melt this down, this is what we would be left with: the chocolate chips and a big puddle of gooey ice cream. So if we're looking at matter as homogeneous matter, what we were talking about earlier on the concept map going down that pure substance line, right here, pure substances, we know that it could either be an element or a compound. If it's an element, it means it's not allowed to be separated into simpler substances, at least not by ordinary methods. If you can take two or more elements that are combined in fixed proportions, that's what's considered a compound, and they can be further divided by chemical means. Some of the ideas to do this is what we call we have right here, we can separate our mixture by filtration. And we can also, well, let's just look at filtration a little bit better. We have before you a heterogeneous mixture. There's some sand, there's some cyclohexanol, and there's some water in there. And they, of course, have divided it out by density. It's insoluble in water and cyclohexanol, the sand, and it's also denser than the two substances, which is why it sinks to the bottom. To get this out, we may want to use a process known as filtration, and I will show you the technique in class on how to set up our filter paper properly into the funnel so that we can collect the sand up here in the top and notice how we're left with water and cyclohexanol down here at the bottom. Now these two substances here have different boiling points. And so if we were to use a distillation apparatus, which I'll show you here in a minute, we could actually separate this off into two component parts where water would be on one side and cyclohexanol would be on the other side. And this is just an example of a distillation apparatus right over here. So notice how we have a flask and we're boiling it with a Bunsen burner until we get to about 100 degrees. And we have what's called this condensation cooling chamber where water kind of just trickles through here and it leaves behind the cyclohexanol over here and the pure water is over here. Now you may know that sailors and things of that nature also do this out in the open sea because they don't have any water, so they'll use a similar process to distill their water, so the salt will get left behind and then they're left with pure drinking water here to the right. So that again is called a distillation apparatus. It's a separation technique based on differences of boiling points, and so because cyclohexanol and water have different boiling points, they're able to be separated off. Okay. A boiling point, what that means is the temperature at which a substance goes from a liquid to a gas. And here's just an illustration of the two. So how we're going to apply this into class is, if you look down here a little bit, we're going to go to the Canvas file folder once you first get into the class, and you're going to open up your Chapter 1 Overview PowerPoint. You're going to locate this slide 5 right here that we had just did. That's going to help lead you through the investigation for the day. So once you have that slide open, you're going to get your whiteboard. I'll show you where they're at, and you're just going to make, oops, I'm going to get better at writing on this thing here eventually. Here's your whiteboard, and you want to make it into sections of 6. And you're going to label it Substance 1, Substance 2, Substance 3, 4, 5, and 6. And you're going to label each substance with what you have over here. First substance will be cherry flavored Kool-Aid, and then you'll have your distilled water for substance 2, etc. So you keep writing those over here into your area. And then you're going to make your own concept map. So we know that everything is definitely going to start with matter. Okay, so matter is going to go here in this little area. Okay, so after that we have to decide, is our substance a mixture or is it a pure substance? If you decide that it's a mixture, I'm sure you'll write a lot better than me. If it's a mixture, then you have to determine if it's going to be a homogeneous substance or a heterogeneous substance. And again, if you need help with those ideas, you can locate those on our PowerPoint presentations on slides 8, I think it's on 9, 7, 8, 9, and 10. Okay, so that'll help you along as you're going through this. And then you're going to just keep on doing that for the 6 substances. Once you complete this concept map, you're going to take a picture and make sure that all of the group members in your group's names are here at the bottom, visible for me to read. You're going to take a picture and you're going to send this by way of Canvas, and you're going to locate the file that says substances. Just one person per group needs to turn this in through the Canvas page. Just make sure all of your names are here. Once you finish completing that task, I will assign each individual group which one they're going to talk about. So group 1 will talk about the cherry flavor Kool-Aid, and group 2 will talk about the distilled water, and your group will just simply let us know how you further divided this down. Once we complete that activity, we're going to go on to something a little bit different, and you're going to do your own design lab. And in the laboratory, I'm going to give you a heterogeneous mixture, and it's just going to be in a little bin like this, okay? You're going to have sand in there. You're going to have iron. And you're going to have salt. And you're going to have sawdust. Okay? So your job is to, on the same whiteboard, once you finish up with it, your job as a group is to design your own experiment on how you can get everything in this heterogeneous mixture into 4 homogeneous parts. That means that this pile should only be salt, this pile should only be sand, this pile should only be sawdust, and this pile should only be iron. Okay? And so you're going to have to develop your own set of procedures, and you're going to have to list all of the equipment that you're going to use. Once you finish that, please have me look it over and sign off on it so I see if you have a good experimental technique. If you do, then you will come to lab, take a picture of this information when you're finished with all of your procedures and your materials. You'll come to lab with this on Monday when I see you, and you'll be ready to go. So at least you'll have half of your lab report pre-written up. Okay, so all you will be doing in the lab then is collecting your data, and that will give you about 1 week after you're finished with collecting your data to come up with your conclusions and write up a nice lab report, which will be due 1 week following your laboratory investigation. So I will see you guys in class, and I hope that this helped.